Hey, all right, students. Let me help you with another one, the third one here on this list. And so let's do number 8 here. This one says, a block slides down a ramp which is inclined at 30.7 degrees above the horizontal. The coefficient of kinetic friction between the block and the ramp is 0.383. The acceleration of the block is, okay. So let's see, if I were to angle it down at 30.7 degrees and put a block on here, it would move down. And this problem is asking for what's that acceleration. Okay. And so like all these problems involving dynamics, we do the free body diagram first. And so I'll put my block here and say, okay, what forces are on this block? Well, I always like to say, take gravity and then everything touching it. And so in this case, we've got gravity, and the only thing touching it is the surface of this incline. And the surface of the incline technically is only one force, but we can think of it as made up of its components, that is perpendicular, called the normal force, and then along the surface. And so this would be the two components of this contact between the block and the surface. All right. So there's my free body diagram. Now, anybody who's watched me do these in the past will know that I say that there's 4 steps to this. The first one is get a good physical picture of what's going on, and the second is to draw a free body diagram. And then the third one says write out the equations. And so I will write out the equations for Newton's second law. And in this case, there'll be 2 equations because we've got an x components and y components. Now, before we call anything x and y, it's nice to put a grid here. And so my hint to any of you who have been watching my videos is when you do these dynamic problems, again, step 1, good physical picture, step 2, free body diagram, but right at the start of step 3, when you start to write out the equations, you need to choose a grid. You need to choose an x and y axis. And it's worth repeating that the best axis that makes the math the easiest is when you can pick one of your axes to actually be the direction of the acceleration, okay? Or a component, if you know the component of the acceleration, like in circular motion. So what I mean by that is we know the block moves down the hill. So let's put, and I'll put this in green, let's call down the hill the x-axis. And since the y-axis has to be perpendicular to the x-axis, that kind of dictates the direction of our y-axis. But just to point out, what's nice about this is that's going to make this term, the acceleration, just a. There won't be a sub-x or anything because it's just all the acceleration. And then that one will also be 0. Whereas if we didn't do that, we would probably have to have a cosine of some angle and then a sine of some angle. And it makes it a harder problem. And so all of these ones involving Newton's laws, I've been saying, do these 4 things. And then at step 3, I've been saying, hey, pick an axis that the one axis, and probably preferably the x-axis, is along the direction of the acceleration, or the component like the centripetal acceleration if we're moving in a circle. All right. Now, maybe the disadvantage is we've twisted it from the traditional axis, and that alone can be a little bit of challenging. But hopefully by this point in the semester, you're getting used to doing a non-traditional and a kind of a twisted axis. And so as you look at this, you'll see, and I'm just going to draw in an extension of the y-axis here, that one of the negative things of twisting it is I don't have the full force of gravity along the y-axis anymore. I've got it in components, and if I were to maybe draw in a blue color its components, there would be a force in the y-axis and also a force in the x-axis. So there should be a term that goes for each of these, and it would be this angle here, which we can probably come back and figure out that this angle here has to be the same as at that angle, because let's see, this angle plus this doubled angle has to add to 90, but also the angle I'm looking for and this doubled marked angle have to add to 90, and so that makes these two have to add up the same, the 30.7. So if I say this is my angle theta, I want opposite of that. So the x-axis would be mg sine of the theta, whereas this one going into the y-axis would be negative mg cosine theta. So again, going to add up the forces. And I might have picked the hardest one to do first, but it's the one that I tend to do first because it's the force of gravity. Then I do everything else. But that would have an x component in the positive direction and a y component in the negative direction. All right, now looking at my other forces, this would be the force of friction. It would be the negative x-axis. So I'm going to put, oops, that's not x, this is x, negative. And that would be the force of friction. And it doesn't have a y component. And then over here, the normal force is all y and no x. So there's my three forces, where force of gravity has both an x and y component, force of friction only has x, and the normal force only has y. So that's another advantage, by the way, of tilting your axis, is you just made the normal force, and the frictional force along your axes. If you left the traditional one, then you'd have components to that. But you wouldn't for the gravitational force. But either way, it's not about the components of the force of gravity. I mean, the forces, it's about the components of the acceleration that I think make it worth tilting your axis for. Okay, so then that has to equal, and this would be mass, and this is what I was saying earlier, this would be mass times the total acceleration. There would be no sine or cosine to have to worry about, and then over here it would be 0 because it's not accelerating in any direction. And now we can get to the fourth step, and so let me review. Step 1, good physical picture. Step 2, free body diagram. Step 3, write out the equations. And step 4, solve the equations. So as I go to solve this, I can say, well, the normal force would be mg cosine theta, okay? And then over here, let me just write this as mg sine theta, and remind you listeners that the force of friction is the coefficient of friction times the normal force, which is perfect, because I'll take the coefficient of friction and then the normal force I just did, so I'll put that in, mg cosine theta equals ma. And then we can see every term has an m in it. That's good. The g shows up in both terms, so I'll factor it out. So I'll have a sine theta minus a mu s cosine theta. Then I can put in my numbers. So 9.8 for g, sine of 30.7 for the angle. Now, coefficient of friction was 0.383, so 0.383 cosine of 30.7, and that equals A. All right, and so now I'll put in my numbers. Let me just check the mode of my calculator. Okay, I'm in degrees. Maybe I'll do this inside piece first. So let's go sine of 30.7 minus 0.383 times cosine of 30.7. And then whatever I get there multiplied by 9.8, coming up to be 1.76. So I get 1.76, and this here, with in rounding, 1.78. All right. Hope that one helps. Take care.